different level, we have faced with problems. Now we will take up a problem on circular arches which are subjected to gravity loads. So now we will take another example. So find the reactions. Find the reaction of a circular, that is also called as segmental arch, circular arch of span 20 meters, and rise 4 meters. You find the reactions of a 3-hinge, okay, 3-hinge circular arch span 20 meters, rise 4 meters, subjected to a UDL of 20 kilometers per meter on right half of span. The supports assume the supports to be at same level. Also, we can determine bending moment, normal thrust, radial shear at any section. So that also can be. So it is circular arch. That means if you take a circle like this, only a portion of the circle, that is called segment. That is only a portion of the circle is called segmental arch. It is portion of the circle. It is not parabolic, it is a portion or segment of a circle. Either the arch may be segment, a small portion, or it may be semicircle. When it is semicircle, it has to be at same level. Problem has to be only at the same level. It cannot be at different levels. A segmental, a semicircular arch means the supports has to be at the ends, that is exactly at the end of the diameter. So it cannot have any up or down. It has to be at the same level. Segmental arch, of course, it can be at higher level or lower level, but for analysis purpose only we take one portion of the arch which is similar to your parabolic arches which are at same level. Generally problems on these circular arches will be only at the same level, nothing other than that. So let us take this example. So this is circular arch, that is a portion of the circle, 3 hinges. That means 2 hinges will be at the ends, supports, and 1 at the apex. So here the height, vertical height at the apex is called rise, and that is given as 4 meters, and the span, which is the distance between the 2 end supports, it is given as 20 meters, and it is subjected to a uniformly distributed load on right half of span, that is this, with intensity of 20 kilonewton per meter. So this is the problem given. Right? Now you have to find these support reactions. Here the horizontal reactions at the support, they will be equal because only vertical load will be there. If you apply sigma h equals 0, you will get HA minus HB is equal to H. The 2 horizontal reactions will be for completion. And the 2 vertical reactions, you have here BA, here BB. So you can adopt sigma h equals 0 first, then immediately you can say HA minus HB is equal to 0, or HA equals HB is equal to H. So that is the first thing. Then you take moment about one of the support, either left or right support, then you will get the other one reaction, that is VB into 20 like this. Then this H, VA will not give any moment, only this, that is minus. So 20 into 10 into 15. So that should be 0. So our VB is equal to
150.
200 into 15, that is
3000
divided by 20, that is 150 kilonewtons. So VB is 150 kilonewtons. Then you can apply sigma E equals 0. You have VA plus VB, which is equal to 20 into 10, that is 200. So our VJ is equal to 200 minus VB, that is 50. So this is 50 kilonewtons. Then H, you can find out sigma MC equals 0. You take what's left, it is easier. So you will have 50 into 10 like this, or minus H into 4 is equal to 0, or H is equal to 500 divided by 4, that is 125 kilonewtons. That's all. So you have been asked to find only the support reactions. So they can find the moment at any section from left, right, only that. So we will take that also. So level also find normal of the moment, normal thrust, and radial shear. Radial shear at a section 5 meters from left. So here it is section X, which is 5 meters from left hand. Have to find bending moment, normal thrust, radius. So in parabolic arch, you will determine y using the parabolic equation to parabola. Either y equals 4hx square TL minus x, or y is equal to kx square, choosing origin either left or at the apex. But here, so it is segmental arch. You have to find an equation to the circle. That's all. So that is the only change. Otherwise, it is similar to your parabolic arch. So let us assume this segmental arch has an origin center at O. So you take this as R. This is H, this is A, B, C. Right? So you call this R as the radius of the arch. Even this OC is also R. So let R be the radius of arch, circular arch, that is segmental arch, like this. Then we have, I think you have already know from the chord rule of geometry. Chord rule says this L by 2 into L by 2, because this is span L. This is exactly at the center. So L by 2 into L by 2 is equal to H into this distance in a circle. The segmental rule says if you have A, B, C, like that, then A into A is equal to B into C. A, B, C. That is what the card rule says. So we have from card rule of geometry, so this L by 2 into L by 2 is equal to H, this is H, into other one is 2r minus H, correct? The other distance, this, that is 2r minus H. This is the equation for finding R. This you have to remember. Only this is the change in case of analysis of circular arch. That for finding bending moment, normal thrust, radius here at any section. So first find this. Here this is L square by 4 is equal to this 2RH minus H square, or R is equal to L square by 4 plus H square divided by 2H. Correct? So this you can simplify, that is L square plus 4H square divided by 8H. Correct?
Yes, sir.
8H. So therefore R is equal to, here L is 20 meters, 20 square means it is 400, then H is 4 meters, H square is 4 square 16 into 4, 64 divided by 8 into 4, 32.
14.5.
That is equal to 464 divided by 32, that is 14.5.
0.5.
That is so many meters. And once you get R, then you can find out at any distance X, what is Y, that you can find out. Or you can find tan theta also. At any section, right? And from suppose OA, this angle we can call it as alpha, that is angle subtended from one of the support with the vertical apex. This angle at any section with again vertical, we can call it as theta. This theta is required for computing normal thrust radius here. If you draw a tangent here, this is normal. Radius has to be normal to the tangent. So when I call this as theta, this has to be theta. Correct? Because this is theta, so from this is 90 degrees to that, right? So from this particular triangle, if you take here, at any section, tangent, this angle, this will be 90 minus theta. So this has to be theta. So that automatically this theta should determine. Okay. Now you can find that theta. Theta as well as alpha. So tan alpha is nothing but from this particular triangle,
Opposite by
this tan alpha is equal to L by 2
L by 2.
divided by, not tan alpha, okay, we'll take the tan alpha. This height, we can call it as some H1, right? L by 2 divided by H1. So tan alpha is equal to L by 2 divided by H1. So if I determine H1, then or alpha, then this H1 can be evaluated. For determining alpha, what I will do is, I will take cosine theta, sine alpha. So we know we have sine alpha is equal to this opposite side, that is L by 2 divided by R. L by 2 divided by R, that is L by 2R. Therefore, alpha is equal to sin inverse L by 2R. Now you have determined all these values R. So L is known, so you can find alpha. That is sin inverse. L is 20 meters, 2R. 2 into 14.5, it is 29. Right? So you can evaluate what is
43.6.
alpha. 43.6
3.6.
degrees. So tan alpha is equal to this. Therefore, we can find out H1. H1 is nothing but tan alpha divided by L by 2. So that is tan 43.3 divided by 10. L by 2 is 10. So you can evaluate H1.
0.09.
0.094.
094.
H1 now.
Yes, sir.
Is it?
Tan, so that is tan of alpha, tan 43.3.
Tan alpha is equal to L by 2 by H1. Or H1 is equal to, how much you got?
Sir, H1 tan alpha is 0.94 divided by 10.
H1 is equal to, sorry, H1 is equal to L by 2 divided by
Tan alpha.
tan alpha. That is 10 by 10 of 43.3. How much? That is you have.
10.6.
Huh?
10.6.
10.6.
6.
So this is 10.6. That's reasonable. This height is 4, right? L. So it is 14.6. That is even R. That you have only top again. So R will take this as 10.5 R. This, if you have rounded up,
Yes.
roughly, because R, this is 2R,
2R.
right? 2R means it is 28.5. So from center, half of that,
14.
that is that. That's okay. What we have done is okay. This you cross check here. Okay. Now when once I know H1, my main aim is to find Y. Because if I determine Y, then bending moment at any section is this H into Y, VA into that X, and due to load, we can find out. And also normal plus radius here, we can find out reaction here, horizontal, vertical axis, resolve along tangent and normal, you will get normal plus radius here. For that again, this theta to be determined. I will determine that theta here. Theta, for finding out the theta, so this is alpha, this is that H1. Now, so this is Y. So Y is equal to, you can say, from this particular triangle, O, this I will call it as some point P, this as Q. From triangle OPQ, if you take OPQ, this is R square, this is H1 plus Y whole square, and this is your distance L by 2 minus X. So from triangle OPQ, we have PQ square plus QO square is equal to PO square. That is opposite side, adjacent side, that square is equal to hypotenuse. That's it from that. So therefore, this PQ is nothing but L by 2 minus X whole square. This is at that section end. So this is L by 2, this is known. L by 2 minus X whole square, and QO is nothing but H plus Y. This H plus Y whole square is equal to R square. So from this is L by 2 is 10 minus X is equal to 4 meters, 5 meters. x is equal to 5 whole square plus h is 4 plus y whole square is equal to, correct? H1. No. This is H1. H1 plus y.
Yes, sir.
QO is H1 plus y. H1 is 10.5. 10.5 plus y whole square, that is equal to 14.5 square. Find or this is equal to 25. So plus this you can simplify, 10.5 square plus y square, or you can just write like that, 10.5 plus y whole square is equal to, what is this, 14.5 square minus 25.
210.25 minus 25.
That is 14.5 square minus 25.
185.25.
185.25.
5.25.
So therefore, 10.5 plus y is equal to square root of 185.25. That's easy way.
13.61.
This is
13.61.
30.61.
13.61.
6. Therefore, y is equal to 13.6 minus 10.5. 3.1. So you got that right. So this much calculation you have to do. The parabolic arch, it is easy. Y equals 4h x by x square, you can use it. But here you have to find out r as well as at any section what is that height y. This is the only change you have in circular arch analysis. Other than this, there is nothing. It is all only from geometry, simple geometrical calculation. Therefore, you can find out. So, bending moment Nx is equal to, I will take free body diagram towards left side, that is h, which you have already determined. So that is first Va into x minus hy. That is your bending moment at that section. Find bending moment at any section. So Va you have already determined, that is 50, x is 5 minus h is 125, y is 3.1. So you have found out bending moment. Then normal thrust Nx. So before finding Nx, you have to find what are the reactions at this point. Here, if you take free body diagram, I will show you. You resolve that along horizontal and vertical, you will get that. So at any section, you have to find out these things. So this is H 125 and this is B 50. This is X, which is equal to 4 meters, and this is Y, which is nothing but 3.1. These are the things which you have to get. This is your xx. So at this point, you find out what is hx, what is ex. This hx is nothing but 125, simple equilibrium condition, and Vx is nothing but 50. There is nothing. So this Vx is 50. Now you can resolve this Vx Hx along tangent and along normal. That is, you will get radial shear normal. This is tangent at x, this is normal at x. So this is your theta, whatever you have already valued. So your Mx is nothing but normal thrust, at x, which is nothing but, so this hx you can resolve along and normal and along tangent, like that. Similarly, Vx you can resolve along the tangent and along the normal. It is like that. Right? Therefore, if you take normal thrust, it is this. Here it is like this. Here it is like that. So this is theta. This is also theta. So with reference to this, this is sine. Right? So which is nothing but hx sine theta, because this is, we are determining normal thrust, that is this component, of course it is cos theta. This component along the tangent is normal thrust. So this component is adjacent, which is hx cos theta, which is like this, and here it is like this, Vx sin theta. Yes, Vx sin, both in the same direction. Then Rx, that is radial shear at x, that is this component. This is down, then
That's also down.
both are down, no? So this
should be
has
up,
to
sir.
be like,
Yes, sir, that's up.
it has to be like
Up.
this.
Yes, sir, that's plus minus.
So this is
Minus.
positive because it is in the R direction.
Yes, sir.
This is negative.
Negative.
So that is at Vx, this
Sin theta.
Vx cos
Cos
theta
theta, cos theta.
minus
Hx sin theta.
sin theta. That's all. So theta is, we have determined, Hx, Vx, we have determined. So normal thrust, radiation. Bending moment, we have already got.
So theta value.
Theta, whatever you have to
43 point, that is alpha.
Oh, that is alpha, huh?
Yes.
Okay, theta I will determine. So to find theta, I will show you. Again, from that angle you can find out. So here, tan theta is equal to PQ by R.
PQ by R.
That is very simple. PQ is nothing but L by 2 minus X. That divided by. So, find. This is to find. That's a simple calculation. So similar to the alpha. So that is one. So with this, we have finished analysis of parabolic arch, circular arch. Circular arch you have to be careful in the geometry. Otherwise parabolic arch is very simple. So next we will take up cables.